Hey, what's up everybody? Mark Price here at devslopes.com, and today we are going to work on getting an obstacle in our scene here. And we're going to write some more code, and you're going to learn a little bit more about Unity 3D. So first things first is let's find the object that we want to use. I've already kind of mapped it out in my head. The one I want to use is this lava rock. Just got to find it here. And there's this one, and there's this one. I believe it's this one that I want to use. Rock 04 underscore lava. And I'm just going to drag it on to the scene. Now, it's not anywhere where I really want it, as you can see. So I'll just move it. There we go. Just press Q to go into pan mode here. And okay, so it's right there. And so we're going to do our game a little bit different than Flappy Bird. It's a little bit small. I'm going to press E to scale it bigger. And that's looking real good. So what I want to do is in our game, you're going to have this one floating rock, okay? Well, just like the towers in a Flappy Bird game, those little pipes, the Mario pipes, okay? In this case, we're just going to have this rock that goes up and down, and you got to dodge it, okay? And so in this video, we're just going to get the up and down movement going. It's going to be moving along with the stuff and moving up and down, but in this one, we're just going to get the up and down movement. And so a few things anybody can think of when they're starting to build this is, well, how high does it go and how low does it go? Well, that's up to you, the game designer and developer. If we move it up, we probably want it somewhere around there. So you can still see it on the screen. And as far as down goes, probably somewhere around there. Okay? And so those are the ranges that we want to hit. Just back and forth, back and forth. Now, these objects here, okay, they're moving from the right to the left, and then they move back to the right when they've moved to a certain spot. We're translating them continuously. In our case, ours has a repetitive motion where it goes down and back up and down and up. And so I think there's some better tools we could use. We could do it the very similar way that we did this, where we're just using like the vector3.translate, and then when it gets to a position, we translate it in the opposite direction. But I think there's a better way, and there's some other things that we can learn today, specifically coroutines. So here we go. We got the object that we want. I'm going to go ahead and go to my scripts folder here, right click it, go to create new C# script, and we're going to call this rock. I'm going to double click to open the file. There we go. Or not. Scripts, there it is. Okay, so this is our old script. Here's the rock. I don't know why it didn't open for me when I double clicked it. Okay, so what do we need to do to get this rock going up and down, up and down? Well, we already talked about the first things first, which is defining the top and bottom positions. Now, we only need to worry about the Y position specifically, but I'm just going to put in a public or serialized field for an entire vector3, just in case in the future if we ever did want to change it, we'll just make it easier on ourselves. So we're going to say serialized field, okay, vector3, which has a X, Y, and Z position inside of it. We're going to call this top position, and serialized field, we're going to say vector3 dot bottom position. Okay. Yeah, that looks good. Okay, so top position, bottom position. Let's go ahead and define those in the game since we know we're going to need those. So we're going to find our script here, this rock, okay, and we're going to, let me rename this rock here too. We're just going to call this rock. And I'm going to drag and drop. In fact, let's click our perspective here so we can know exactly where we are. There we go. Seems so high. Okay, there's our bridge. There's this right here. Okay, so here's our rock. Let's drag the rock script onto it. And you should see the top position and bottom position public variables there. Okay, so what we're going to do is just record them. So we know that we wanted our top position. I'm pressing Q to pan and W to go into move mode here. Move right about here. Okay, so we know that our local position here for the Y is 1088. So what we're going to do is we're just going to do the Y. Okay, we're just going to do the Y. So the top position is 1088. And then for the bottom position, right about there. And this is negative 1.25. So Command C or Control C, And for the bottom position, we're going to put it there. All right. What I'm going to do is move it back to the top position. We'll start off in the top position. So just change this back to the top position, and there we go. So this rock's going to be moving up and down, up and down, up and down. And what we've just done here is we've set the serialized fields to hard code in the top and bottom positions. And it's looking good. Okay, so how do we get this thing moving up and down, up and down? Well, last time we just did in the update function here, we just checked positions, and if it was some other position or beyond a certain position, we move it back. We could do the same thing here. We could say translate vector3.up if we need to go up, and then once we hit a certain position, we turn it to down. But it's not going to be very smooth, and I think there's some enhancements we can do, like maybe wait a second or half a second when it's at the bottom before it goes to the top, and vice versa. Give it a nice smooth transition so it's just not game development is all about the finesse, the touch, you know, the smoothing. You know, it's not enough just to pop up the screen. Things should be animated, okay? If you're a long-term programmer and you're used to just doing very hard mathematical things, you're gonna have to add a little more creativity to your code because things need to look nice. This is a game. Okay, so how would we do this? Well, we're gonna learn a new concept today, and this is called a coroutine, okay? So what we're gonna do is we're gonna create this function of sorts called IEnumerator. We're gonna call it move, okay, like so. So what is an IEnumerator? Well, this is an interface in C#. So this is a C# thing, and this is an advanced topic in C#. Okay, I'm not going to dig into the details of IEnumerator. You can go look up on Google what is an IEnumerator in C#. More or less, it's a very special way of enumerating through objects or through anything that you want to enumerate through, which you might not be able to normally do like in a for loop of some kind. And specifically for us, it's using a coroutine, so things that have time in Unity, okay? So like if we want to pause for a few seconds or we want to move something within a certain period of time, we can do that inside of this IEnumerator. Now again, it's complex, very, very complex. And so the best thing I can recommend that you do right now is just read the Unity documentation on coroutines and look at some of their example documentation, and you'll be able to see how they're using it and what it's for. And you'll learn a little bit more as we move along here. So what do we want to do? What we want to do is we want to move the object down, and then when it gets down, let's pause, move it up. When it gets up, pause, move it down. An infinite loop of movement. But we're not going to use the update function at all. In fact, we can just get rid of it here. We're going to use a coroutine. Okay? And again, the most important thing I could ever tell you about coroutines is when you need to have pauses or move things over a period of time and wait, and you need to be able to just have timings and things like that. Think of a video game like where a first-person shooter or third-person game where you're walking a dungeon, a third-person game. You're walking through a dungeon, and all of a sudden, it's time for the boss battle. So the cave behind you breaks in, okay, and then these enemies spawn. You know, you could use a coroutine for that. You could say, okay, once the player has passed this trigger, I want to wait 3 seconds, and then I want to make the rocks fall down. Then I want to wait 2 seconds. Then I want the enemies to pop out, and then I want to wait 5 seconds, and I want the boss to come out. And you can do that all with coroutines. Okay, so what do we want to do? Well, we want to check if it gets past a certain position, and then move it the opposite direction. So we're going to do a while loop here, okay? And we're going to say while mathf.abs, okay? Mathf.abs is basically the absolute value. Whenever you're working with Unity, this is so important. Stop and listen to me right now. When you're working with Unity or games in general, you're going to be working with positive numbers and negative numbers, okay? If you want to check the distance between 2 points, okay, you can't always just say, you know, A minus B. You can't do that because some are negative values. Your numbers are going to be wrong. Like if you're in the negatives and you want to, and that's, let's say, point A and point B is in the positives, you can't say A minus B because to get your distance, because it's going to give you inaccurate information. So you need to always get the absolute value when you're working with negative numbers, when you want to work with distance and things like that, okay? So that's what we're doing here. We're just ABS. So if I pass in, let's say, a negative 10 here, that's just going to produce the value 10. Okay, ABS. This is high school math. Absolute. The absolute value. But of course, we don't want negative 10. this is what we want to do. We want to put in the target of where we're moving, okay? The top position or bottom position. Well, how do we know which one we're moving towards? Well, maybe we need to put a parameter here in this function, okay, called target. And what we'll do is anytime we call this move function, we'll pass in if we're going to the top position or the bottom position. So what we want to do here is not -10, but we want to say target minus transform dot local position, okay, local position, and we're going to say, actually, in fact, let's put this in parentheses as well, okay, because what it's going to do here is it's going to subtract the vector 3, okay. So this is what's going to happen here. Target minus transform to local position. Well, local position is a vector 3 and target is a vector 3, okay? So we're going to take one vector 3 and subtract another one, okay? And then we're going to get the result of that, which is, or we're going to grab the y result, okay? This one minus this one, and let's get the y, okay? The distance between the y point. We don't care about the x, we don't care about the z, okay? And then we're getting the absolute value of this, okay? The positive number, okay? And so what we're going to do is we're going to say if it's greater than 0.20f, okay? So why am I doing that? Why am I saying, wait a minute, if the target where we're going versus where we currently are, if we're subtracting that and getting the difference, why wouldn't we just say if it's greater than or equal to that? Well, the thing is, when you're working with games, okay, there's frames, okay? And they're always updating. Well, it can actually skip a value. So if I was to actually say 0.05, that number is so small that it's very possible that it would skip over that number, and then this function would never be called here, or we'd never go into this while loop, which is not good. And so I'm just giving myself a little bit of a spacer here. I'm just not saying, I'm not making sure that there's 0. I'm actually just giving a little bit of a spacer. When it's about 0.20th of where it should be, then we're going to move it back, and that gives us some time to stop, okay? And you can play with these numbers to see what I mean. Okay, so I'm missing my closing parentheses for this while loop. Okay, so mathf abs, okay, so we're passing in this abs the absolute value of this y position, and of course this y position is calculated by taking this vector here, subtracting this vector here. So where we want to go to where we currently are, subtract that distance, get the y distance from that. We don't care about the z or the x. And then if that's greater than 0.20, meaning we're further out than the stopping point, then let's move it, okay? And if this is really confusing to you, just read it over and over and over again until you understand it, okay? I like to draw things out in my head, map things out on paper sometimes. Like, it's okay to draw pictures. I do that all the time. If you need to draw pictures with this, like one object subtracting this object, go ahead and do that, whatever it takes, okay? So now that we know we need to move, this is what we're going to do. We're going to create a new variable, vector 3. I'm going to call it direction, and we're going to use a ternary expression here to determine which direction we want to be moving. So if target.y, so if where we want to go, the y position of it, is equal to top position.y, so if the place we want to go is the top position, that's all we're saying here, then let's move up, vector 3.up. Otherwise, let's move down, okay? So ternary expression, if you're not familiar with ternary expressions, this is how they work, okay? You create your variable, and then you say equals, and then it actually performs an expression here. So it's going to run this calculation first, okay? We're saying if target.y is equal to top position.y, and the question mark means go ahead and run this expression and see what the result is. So if these are the same, then it's true. So this is the true, okay? So it means store vector 3.up into this variable. If it's false, okay, this is what means false, the other side of this colon here, we're going to use vector 3.down. So 3 parts of this ternary expression, right? So we do the expression here, okay? The condition is what I meant to say. We do the condition. If target.y is equal to top position.y, so if the direction we want to go is the exact same as the top position, then let's move it up. Otherwise, we need to move down. That's all, okay? I could have done a bunch of if-else's, but this is really clean and it's one line of code. And it's important that you as a developer learn how to use ternary expressions, ternary operators. It's T-E-R-N-A-R-Y, ternary. Very important for you to learn, especially in games. Okay, so then we're going to do, so we're going to say transform dot local position. Okay, and this is the transform of the current object that we're going to throw the script on, okay? Plus equals direction, okay, times time dot delta time. Okay, so all we're going to do is say, hey, add the current direction to the local position. That's it. And we've worked with time dot delta time before. You know what that does. Okay, and here's something new. Yield return null. So IE numerator can return multiple things. Okay, and in this case here, we are just returning null. Like at this point, after we remove, we return nothing, and it's going to keep doing this for loop. So unless we return something, it's going to keep being called and called and called. So we're returning null. We're returning nothing. So this operation can continually repeat. Okay. I know it sounds weird. Usually when you do a return statement, this whole function would exit. That's not the case. That's why IE numerator is very special. Okay. We can return null, and it will keep running this loop here every single time. In fact, this thing actually doesn't end. You can actually run it multiple times. It only ends when you tell it to end, which is really interesting, right? So basically all that's happening right here is we're moving in one direction or the other over and over and over again in this for loop within this function. Okay, no need for an update. This is very complex. It takes time. It takes many practical applications to understand it. So you can watch this video again and again, of course. And so basically at this point, we've reached the target. Okay, so if we get out of this function, we're where we need to be. Okay, we're not returning null anymore, and then it's going to move over here, which is cool. One interesting note is you've seen us use debug.log, and you've also seen us use print. Okay, just know that the print will actually use the debug.log under the hood. Okay, but just know that if you're not inheriting from mono behavior, you cannot use print. So if you're creating your own class that is just like data only, no Unity stuff, okay, if that's what you wanted to do, and you don't inherit from mono behavior, you have to use debug.log. Okay, and also debug.log, you can have multiple parameters, and print you only do one, but it's fine for now. And then what I want to do is what I was telling you before, is I want to create kind of a pause. So yield return new, wait 4 seconds. That's a Unity thing. Okay, 0.5f. So I want to wait half a second. So we've moved, we've gotten to the point we want to be. Then let's go ahead and wait 5 seconds, and then we're actually going to start this function over again. Okay, so we're going to do a very similar thing down here. We're going to say vector3 new target. So this is the new direction, right? Equals target.y equals top position.y. Same exact logic, right? Bottom position, otherwise top position. Let's explain this here. So the new direction. So if the target of where we were going, so now we know we've reached our target, right? So that if the target up here where we were going is same to top position, it means we've reached the top, which now means we need to move to the bottom. Otherwise, we were going to the bottom, and now we need to go to the top. That's all. So how do we call this function and start it over again? Simple as start coroutine. This is a Unity call to a coroutine is what they call it. And you just pass in the IE numerator function, and then you can pass in the data that you want to pass into it. In our case, new target, the new direction that we want to go. So this is going to call itself over again with the new direction in it. And the last thing we probably need to do is simply just call the move coroutine from up here when it starts. So start coroutine, move, and since we're at the top, we want to move to the bottom, right? So we're going to type in, we want to move to the bottom position. Okay, so we start coroutine. We want to move to the bottom because we know we're starting at the top. While it's going to run some math to see how far apart they are. If it's greater than 0.20th, okay, then let's just keep moving in that direction. If it's not, meaning if we're less than or equal to this value here, it means we need to stop, and we've gotten to our target, and then we need to wait for a half second and then move into a new direction. Okay. Again, if you're confused at all, you can do this video again and again. It does take time, but I don't think there's anything more I can do to explain it. It just takes practice at this point. So here's our rock, okay? And nothing else we need to do except run it and see if it's actually working. So it's moving down. Pretty slow, but it's definitely moving down. Let's see if it stops and goes back up as we would hope. Okay, it stopped, and now it's moving back up. Moment of truth is if it stops at the top. Isn't it crazy to see this? We didn't write that much code, and we've got cool things happening in our game. Okay, so it stopped. So this is looking real good. So we do have a problem, though. It's really slow, like really slow. So why don't you pause this video, and I want you to stop and figure out right now how you can make this object move faster. Okay, so pause the video and figure out how to make the object move faster. Did you do it? If you didn't pause the video and do it and you're still watching it, I'm gonna punch you. I'm just kidding. I'm not gonna punch you, but you should have done it. You need to learn this stuff. So what I'm gonna do, this is my solution, is I'm gonna create a serialized field called speed, and then down here, I'm just gonna add it to after the time.delta time, so times speed. This is kind of like what we did before, right? In the object. So direction times time.delta time times speed. And let's go back over here and go to our rock, and it should update here. Speed, let's say 5, and play it. And there it goes. It's moving. It's moving a little bit fast. Okay. One thing that's really interesting is, you know how we had that 0.20th if we're within 0.20th of a range, and how you can skip things? If I increase the speed by a lot, look how it just went through. It skipped it. It was going so fast that it didn't have time to get within that range, and it skipped it. So that's why it's very important that you calculate these things and test these things, because especially on different phones or computers, because things have different frame rates. Really, really important. So just something to think about. The speed was too fast. I'm going to try a 3 and see how that is feeling. Okay, so it's going down. This looks like a really good speed here. Stops, goes up. Boom. This is looking good. So it's going up and down, up and down. You know, some other fun things we could do, which we're not going to, is we could throw a rotation on this, and you could spin around in a slow circle, revolving as it's moving. But this is coming together. So I like it. What do you guys think? Good stuff? Cool. So in this exciting lesson, you learned about coroutines. You learned about IE numerator. Let me unpause this here. And what's cool about coroutines is you can use as many returns as you want in these. Return new, wait 4 seconds. And so I could have put another one here and another one here to do different things if I wanted. We also learned about mathf.abs. This is Unity's internal math classes with different functions. And so we took the target position and the local position, the y value of that, to get the absolute value of the distance and see if it's within a range. And if it is, we'll move it or we'll stop it, whatever we want to do. And we've got some life in our game. So cool stuff. That's it for now. Mark Price at devslopes.com. Moving on and forward.